2, 1. All right, so let's take what we learned up here about the quotient and answer a question that you'll probably for sure see on the AP exam, and for sure on my exam. The graph of the equation x squared plus y squared equals 4. You might recognize that. It's a circle centered at the origin with a radius of 2. In general, the equation is x minus h squared plus y minus k squared equals r squared, and we have a center at HK, and we have a radius of R. Okay, that's not necessarily something you need to memorize, but I don't know if that showed up in algebra 2. So in this case, it's x minus 0, y minus 0, so the center's at the origin. This is 2 squared, so the radius is 2. All right, so it says to sketch the graph of the equation. So here's how we sketch the graph of a circle. Right, we need an x-axis and a y-axis, or vice versa. And since it's centered at the origin, that's nice. All you got to do is go out 2 units in both directions and graph a circle. Now, because Notability has circle capabilities, it's just so nice being able to do this. Then we can move the circle, and we can just try to center it. It probably centers it too, I guess. But let's just say that this is 2. And then we'll cut that in half and call it 1. This will be 1. This will be 2. -1, -2. Hello. -1, -2. There we go. Oh my gosh. It's Brody Neptune, Neptune Brody Poseidon.
Did he have a costume on before?
No. No. Yeah, he wasn't even here. Okay, so there's our circle. He got yeah, okay. I was trying to think of an ocean joke, but anyway, the circle's right here. We graphed it, right? Pretty easy. And it says now to find dy dx. Well, how are these related? Well, I don't know. Let's see. I got x squared plus y squared equals 4. It's not solved for y. Do you want to solve it for y? Can we solve it for y? We actually can, right? Pretty easily, but it would require 2 equations, yes? It would be the square root of 4 minus x squared and the negative square root of 4 minus x squared, right? One of them would be the top portion, and one of them would be the bottom portion. So I don't want to have to work with 2 equations when we could just work with 1, right? Would y'all want to work with 2 rather than 1? I mean, usually more is better, usually, but in this case, I'm not interested in that. So you know what? I'm not going to solve it for y and use 2 different equations, especially this reason. If I did even do that, I have 2 equations, but if I were to take the derivative of those, look, it would be like an ugly chain rule. 1/2 blob to the -1/2. We're going to have like a denominator and radicals. Yucky, yucky, gross, gross. There is a method for taking the derivative without solving for y, right? Let's just do it that way. It's called implicit differentiation. So coming back over here to pick a better flavor. There we go. Well, to say d dx colon. And now here we're using this equation up here, right? So the derivative of x squared with respect to x is 2x dx dx, which we don't need, plus the derivative of y squared is 2y times dy dx, which we do need, equals 0. So there's the derivative. Now, at this point, let me just kind of go off on a little bit of a tangent here. As you've noticed, when I've taken the derivative of y implicitly, I've used dy dx exclusively. It's not just because I'm a fan of Leibniz. There is another version of dy dx, right? Y prime. But here's what I've noticed or come to notice about people who use y prime. It doesn't stand out nearly as prominently, does it? And at some point, you can actually mistake y prime for y to the first, right? And then you're like, oh, y to the first, I don't even need the exponent there because y to the first is just y. And all of a sudden it's like, what am I doing, right? Like when we were singing Iron Maiden in Kilford's class, it was like, what the heck is going on here, right? Or shooting baskets in the gym. What in our, oh, what's going on? It's fun, but we have no idea what we're doing. All right, so that's why I would recommend using dy dx exclusively, because you could spot it, right? He literally stands out in the crowd. And you're not going to get that confused for y to the first. So anyway, There it is. Now, to solve for dy dx, just a couple of algebraic procedures. Bring the 2x across, it becomes negative 2x. And then we divide through, and the 2's divide out. So you're left with negative x divided by y. That seems like a much nicer derivative than having two separate derivatives with, those yucky exponents. Bleh. And denominators with radicals. Okay, but it does have x and y in it. So if you want the slope of the tangent line at any point along the circle, just plug in the ordered pair, right? So here's what it says. Using calculus, verify that the graph has horizontal tangents at 0, 2, 0, -2. So we actually know what the circle is, and we know that it has horizontal tangents up here, right? There's a horizontal tangent, and it has another one down here, okay? So what we're doing is we're using the circle, which is familiar to us, so that we can get confidence as we do it with other curves that we don't recognize. So you're probably not going to be given something as tame as a circle. But if you were asked to find the horizontal tangent lines of the circle, you could actually graph it and say 0, 2, 0, -2 without doing a lick of calculus, right? But let's verify that it's at those 2 points. So let's bring the derivative down here, dy dx equals negative x over y. If I want to find horizontal tangents, that's going to be where the derivative is what? Equal to what? 0, okay? So because I have a quotient, here's how you're going to get credit for it. Directly right there, you can say equals 0. It kind of creates like 3 equations, but what you're doing is you're taking the expression that is equal to dy dx, and you're creating another conditional equation. And now we're going to work straight down from this other set. So negative x is equal to 0 when the numerator is 0. What's the numerator, x or negative x? Or does it matter? It doesn't matter, right? You can bring the negative with the x if you want, because it's a single term. So I'm just going to say x equals 0. But if you did negative x equals 0, then you just have another step of multiplying both sides by -1. Okay, so that's what that means. When x is 0, the graph has a horizontal tangent line. Now, how would we find the coordinates? How would we find the value of y that goes along with it? Plug it back into the original. Let's bring that back down. X squared plus y squared equals 4. And then we'll say when x equals 0, right, colon, we get 0 squared plus y squared equals 4. And of course, that's y squared equals 4. When you take the square root, now you have to consider plus or minus, which means y is plus or minus 2. And so what does that mean? For 1x, there's 2 different y values? Yeah. So we have, let's see, yeah, we have, or we'll just say horizontal tangents. Have that. So horizontal tangents. The function doesn't have a name, right? Because it's not explicitly solved for y. So we have horizontal tangents at the point 0, 2 and 0, -2. Is that consistent with what we knew to be true before we started? Yeah, absolutely. All right, and then you would do the same thing similarly to verify where the vertical tangents are. If you look at the graph over here, you can see we have vertical tangents over here on the left and right side, which are at 2, 0 and -2, 0. So to verify that, this is what it would look like. Write the derivative again. And now, what do we want to do? We want to set it equal to the whole thing equal to, you don't want to do plus or minus infinity, right? Because that's 2 answers, and we don't want to guess which one it is. So let's just set it equal to dne. And now we know that we're interested in just when the denominator is 0. And again, if you call that negative y, you would have 1 extra step. And now to find the pairings, we'll bring the equation back down, x squared plus y squared equals 4. And similarly, we'll say when y equals 0, you get x squared equals 4, and x equals plus or minus 2. Pretty easy equation. So we have vertical tangents at, now we pair those up, 2, 0 and -2, 0. Now, if you had the same value that made both the top and the bottom 0, you would have to throw it out. But we don't. These are different points, right? If an ordered pair showed up in both of them, you would just get rid of it. It wouldn't be horizontal or vertical. All right, so that's a verification. Now look at this one. This is a nice little question. At what value of x is the slope of the graph 3/4? Slope of the graph 3/4. Let's look at the graph first, okay? 3/4. 3/4 is a slope. I'll use green here. Let's look at the 45-degree slope. That would be about a 45-degree slope, yes? Or a slope of 1, right? So a slope of 3/4 would be what? Steeper or less steep? Less steep. So let's just kind of draw one that's less steep. There we go. So now let's say that the slope is 3/4. So now let's just copy this. And again, this is kind of cool notability. Let's copy that tangent line. And excuse me, guys, move over here. And let's paste it. And let's move it around until it kisses the graph, right? Right there. And is there another one? I think there's another one, right? Right there. So it looks like there's 2 points. These points should have a little bit of symmetry, right? Don't you think? Like this would be like a negative number and a positive number, and this would be a positive number and a negative number, and their magnitudes, because of the symmetry of the circle, should be the same. Should be the same. So let's go ahead and see. We know it's going to be, well, there should be 2 of them, right? So here's what we're going to do. At what value of x is the slope of the graph 3/4? So now we're going to take our derivative again, dy dx, which is negative x over y, and we're going to set it equal to 3/4. And then we're going to solve. Well, what do you mean solve? I have one equation with 2 unknowns. Am I allowed to go straight across and say x equals -3 and y equals 4? No, you can't do that. You can't do that because there are other versions of 3/4, right? What if 3/4 was in the form 6/8? That's also equal to 3/4, right? You can't say x is 6 now and y is 8. So it doesn't work that way. It doesn't work that way, unfortunately, right? That would be the way that someone who like flies in at the end of our flash mob tries to do it, right? It's like, oh, you're just going to hurt yourself and maybe me in the process. My knee hurts when I see her do that. It was so close to wiping me out. So what can we do? How can we do this? Well, it has to satisfy 2 equations. It has to satisfy that equation, and it has to satisfy this equation, right? So we really have 2 equations with 2 unknowns. Let's bring the other one down. X squared plus y squared equals 4. We know it has to satisfy that equation because it's a point on the graph, yeah? So when you have 2 equations and 2 unknowns, you solve them simultaneously. That means you do one with your left hand and one with your right hand, right? Like, hi, I'm Mr. Kilford. Right? Hey, let's do this. Let's take this equation and solve it for either x or y and substitute it right in here. Does that sound good? Yeah. Hey, so I'm going to multiply both sides by -y. How about that? So this becomes x equals -3/4 y. Right. Or if you want, you can say y is -4/3 x. Are we almost done in here? Oh, man. Okay, so you plug it in, and here's what's going to happen. I'll plug it in for x. -3/4 y squared plus y squared equals 4. Square it, you get 9/16 y squared plus 1 y squared, which is 16/16 y squared. See what I did there? Like terms. And then 9 plus 16, that's 25/16 y squared equals 4. And now if I multiply both sides by 16/25, the reciprocal, right? 16/25, 16/25. I get y squared equals 64/25. And now when I take the square root, I need to consider both plus and minus. So it's plus or minus. Hey, look, those are both perfect squares. The square root of 64 is 8. The square root of 25 is 5. Now all I would have to do with those 2 is plug it back in over here. Did I get that? Did I get the right variable? Yeah. Yeah, plug them back in over here, one at a time to pair them up. Like when you plug in a negative Y, you're going to get a positive X. When you plug in a positive Y, you're going to get a negative X. And those will be your two ordered pairs. Okay. All right. So the bell's going to ring like right now, right now. Now it's going to ring. There it is. Y'all have a great day. Learn the flash mob dance. We'll see some of y'all at tonight's football game. Go Blue!